In this video, we're going to do some examples that have to do with weight and normal forces. So hopefully you've watched the above video where we describe and explore all the difference between weight, mass, and normal force, and how weight is sometimes, or force of gravity is referred to weight, whereas sometimes the normal force is referred to as the apparent weight. So let's look at some questions here. So example 1, Mr. Skaber has a mass of 73 kilograms. On Earth, determine his weight. If Mr. Skaber is standing still on a flat surface, what would the normal force be? So let's just say I'm chilling on a flat surface here. So here I am. Pretty good drawing, very accurate. And let's say that, well, we are told that my mass here of Mr. Skaber is 73 kilograms. Now, it wants us to find weight. Remember, weight is simply equal to the force of gravity. Our force of gravity equation is mg. Now, g here can change depending on where we are and what planet we're on, but we're on Earth. So since it didn't tell us g specifically, but it just told us Earth, we can assume that it's 9.81 meters per second squared. So that's what my force of gravity is here. Or not my force, but my gravity. Now it's a matter of just plugging it in. So at this point, my force of gravity is mg, my mass is 73 kilograms, and my gravity is 9.81 meters per second squared. So my force of gravity, pull up my calculator here, 73 times 9.81, that's 716.13 newtons. And remember, force is a vector, so the force of gravity is down. And there's my force of gravity. I technically should give this the proper sig digs, I guess, for a final answer, so I'll move this decimal over twice. And that'll be 7.2 times 10 to the 2 newtons down. Now let's answer this next part of the question. If Mr. Skaber is standing still on the flat surface, what would his normal force be? Well, here, so far, we have figured out that my force of gravity is pushing down on the Earth with 716.13 newtons. Now remember, if this was the only force acting on me, that means I'd be flying down. I would be moving downwards because my net force would be going down. But I'm standing still on this flat surface, so something has to counteract that force. And that's going to be the normal force counteracting that force. So here, this will be the normal force. And understand that the net force, the force of gravity and the normal force are canceling out. So here, my F net is 0 newtons. So if we want to show this mathematically, I'm standing still. Therefore, F net equals 0 newtons. And we can recall that F net is the sum of all forces. Remember, this means sum. So what are the forces acting on me here? Well, it's my normal force minus the force of gravity. And remember, I'm putting a minus here because it's opposing the normal force. And this is 0 newtons, and that's normal force minus the force of gravity. And now we can solve here. So I'm going to add the force of gravity to both sides. And here we can see that the force of gravity equals the normal force. And it would just be in the opposing direction. So my force of gravity is 7.2 times 10 to the 2 newtons down. So that means my normal force is 7.2 times 10 to the 2 newtons up. And again, that only really occurs if an object is just sitting still, not doing anything. Let's look at B here. Mr. Skaber flies to Mars, where the gravity is 3.711 meters per second squared. Determine his mass and the weight on Mars. So on Mars, what would my mass be? Well, my mass isn't going to change. Remember, that's a fixed quantity as long as I eat relatively the same every day. It's not going to really change. It'll always be 73 kilograms. Now, my weight is a different story because weight, again, is the force of gravity. So the force of gravity equals mass times gravity. But my gravity here is different because I'm not on Earth, I'm on Mars. It's 7.311 meters per second squared. So now I can plug in 73 kilograms times 3.711 meters per second squared. And what do I get my force of gravity to be? 73 times 3.711. It gives me 270.903 newtons down. Now compare that to how much I weighed on Earth. I am almost a fourth of the gravity, right? I'm a fraction of the gravity, or sorry, not the gravity. I'm the fraction of the weight I am on Earth. And that's why when people are in Mars or in space, they feel lighter because they technically are. They're not as heavy. Their weight is less. So this will be 2.7 times 10 to the 2 newtons down. So hopefully you're wrapping your brain around the force of gravity, weight, normal force at the moment. I'm going to stop the video there. And make sure you go check out the next example where we do a normal force example. But this time our normal force changes because of what's occurring. Any questions? Let me know.